Good day everyone. Today I will going to report linear inequality. Inequality tells us about the relative size of two values. We can call things like this inequality because they are not equal. Properties of inequalities. Number 1, additional property of inequalities. For any real numbers a, b, and c, if a less than b, then a plus c less than b plus c, and if a, b, then a plus c is greater than b plus c. Number 2, multiplication property of inequality. Let a, b, c be real numbers. If a greater than b, then ac greater than bc for every positive number c. If a greater than b, then ac greater than b, bc for every negative number is c. If a less than b, then ac less than bc for every positive number c. If a less than b, then ac greater than bc for every negative number is c. Number 3, trichotomy property. If x equals 0, then x is not positive nor negative. If x greater than 0, then x 3 inequality is 0 and x is positive. If x less than 0, then x3 inequality is 0 and x is negative. Number 4, transitive property of inequality. Let a, b, and c be real numbers. If a less than b and b less than c, then ac less than c. Examples: solve 3x plus 2 less than 14. Given number 3x plus 2 less than 14. Next, 3x plus 2 plus negative 2 less than 14 plus negative 2. Next, 3x less than 12. Then 1 over 3 times 3 less than 12. 1 over 3 is equal to x less than 4.
Geometry of linear programming. A linear optimization or linear programming is a subfield of a much broader optimization field called convex optimization. Hyperlanes and half-space. A hyperlane is an equation where areas, a half-space is an inequality. For example, the equation above is a linear in two-dimensional space with coordinates x1 and x2. This is also known as the line equation. So a hyperlane in two-dimensional space is a line. Similarly, in 3 dimensions, this equation is a linear equation and it is known as a plane. In more dimensions than 3, the geometric object is constructed by a linear equation and it is called hyperplane. Half-space is similar to hyperplane, but it covers the area on the one side of a hyperplane. In the image below, the letter N that is in the side is a half-space, while the letter P is in another side called half-space also. They are separated by a hyperplane. In other words, a hyperplane is the boundary of a corresponding half-space.
Polyhedrons. A polyhedron is a three-dimensional solid made by joining together the polygons. The polyhedrons are defined by the number of faces it has. So let's proceed to the parts of the polyhedrons. Every polyhedron has 3 parts. So the first part is the face, second edge, and the third is the vertex. So the face is the flat surfaces that make up a polyhedron are called its faces, and the edge is the regions where the two flat surfaces meet to form a line segment. And the third is the vertex. It is the point of intersection of the edges of the polyhedron. The polyhedrons are named according to number of its faces. So the first example of it is the tetrahedron. The tetrahedron has 4 faces, and the second one is the pentahedron. a pentahedron has 5 faces, and so on. Convex set is a set of points such that given any 2 points A and B. In that set, the line AB joining them lies entirely within that set. That is why the upper plot is convex and the down plot is the non-convex, as you can see at the picture.
First equation is y is equals to 2x minus 3 and the second one is negative 2x over 3 plus 5. So what you want to do, you want to graph the two equations and want to find where the point of intersection, and that's going to be the solution.
Let's put some mark on the graph first. Let's go up to 5 on the y-axis and the same to the x-axis. The advantage of drawing in a big graph is you can clearly see what the solution is going to be. If you draw a graph with the marks closely spaced to each other, it might be difficult to see the answer. So the bigger the graph, the better. Each of these equation is in slope-intercept. From starting with the first equation, we could see that m, the slope, is 2 and the y-intercept is negative 3. We need to go down at least 3 is negative 3. That's going to be the first point. To find an exponent, use the slope. The slope is 2. Slope is rise over run. You have to go up 2 units and travel 1 unit to right. That takes us to the next point, which is 1, negative 1. Let's do it again. Let's go up 2 over 1. So that's going to take us to the point of comma 1. Then if we go up 2 over 1, we're going to be at 3, 3. Up to 2 over then 4 over 5. And that's enough for this graph. Let's graph the second equation. The y-intercept is 5. So we're going to start at a y value of 5. The slope is negative 2 over 3. So the rise is negative 2 and the run is positive 3. Starting from the first point, we need to travel 3 units to the right. That's the run. Then we need to go down 2 units. That is going to take us to the point 3, 3. Now let's check it. Let's solve this by substitution. Let's replace y with 2x minus 3. So therefore, 2x minus 3 is equals to 2 over 3x plus 5. Let's get rid of the fraction by multiplying everything by 3. 2x times 3 is 6x. Negative 3 times 3 is negative 9. Now, what is negative 2 over 3 times 3? Well, if we write it out, 3 is the same as over 1. You can cancel the 3 and you'll get negative 2. If you don't see it that way, you can multiply a cos negative 2 times 3 is negative 6 and 3 times 1 is 3. Negative 6 divided by 3 is negative 2. So you get the same answer whether you cancel or you multiply across. So this is gonna be just negative 2x. 5 times 3 is 15. Now let's add 9 to both sides and add 2x to both sides. 6x plus 2x is 8x. 15 plus 9 is 24. 24 divided by 8 is 3.